Next up, for exercise 2, find the volume of the solid formed by revolving the region bounded by y equals x squared and the x-axis on the interval from 0 to 2, close interval, about the x-axis. Another x-axis revolution. I promise you at some point we'll also do another axis, but for right now, that's what we're doing, all right? Just live with it. How do we start this? Well, let me tell you. I'm going to suggest that we start it by drawing a picture of this situation. Visualize, if you will, that this is the x and the y-axis, and then I need a parabola here. This is looking really good. Look how symmetric this thing is. All right, and I'm going to revolve this thing around the x-axis. The closed interval, I think, was from 0 to 2. Let me block that thing off. Let's say that this is about 2 right there. Doop, 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 doop. So imagine taking this plane region, that's right here, and revolving this thing around the x-axis, going to generate a three-dimensional solid. What the heck is that thing going to look like? Well, to find this volume, we're going to start with our representative rectangle. Maybe a little skinnier. Okay, so just pick a random spot here to draw your rectangle. And I promise you this is going to be really beneficial whenever these shapes get a lot more complicated, but we got to start easy. All right, as I've done before, take this thing, maybe reflect it right about down here for that bottom edge of the cylinder. And now complete your disc like this and this. That is perfect. Yeah, it's roughly perfect anyway. All right, now what two pieces of information do you need to find the volume of a disk? You need a radius, which is going to be this piece that's right there, and that radius is, well, you can see it's just the distance off the x-axis up to that parabola, and that distance there is the function x squared. Right, and then we need a height, and the height is delta x, since we are basically partitioning along the x-axis that's right there. Okay, so we're ready. We're just going to go straight to what that definite integral should look like. It should look like volume is equal to, we have this scalar of pi, don't forget it. Often on a free response question, remember the fact that you have a pi is worth a point. And then also sometimes your limits of integration on this one, probably it wouldn't be worth a point because it basically gave it to you. All right, so from 0 to 2, and then we need our radius function. So it's x squared squared, and then times our height of each of our disks. There you go. Pretty easy to set up, right? Pi 0, 2, x to the fourth, and its antiderivative is x to the fifth over 5, which we will evaluate from 0 to 2. So we get a pi times, I believe that is 32 over 5, and then I'll just rewrite it. Make it look real pretty. 32 pi over 5 units, not squared, come on, it's volume, there you go. 32 pi over 5 units cubed. So have you been able to visualize what this three-dimensional shape is going to look like? I'll give you a hint. It sort of looks like another piece of candy, and this one is sort of a Hershey's Kiss. That's the whole reason why I chose that particular picture for the objective image. You can visualize here that there is an axis. This one's a vertical axis, but if you tilt your head 90 degrees, you can see it as a horizontal axis of revolution. And it's sort of basically like the shape that we just drew. Anyway, it's a more delicious version, and I'm sure that like the rest of this has something else to do with candy too, right? I mean, that's how the candy industry works. Candy industry, and then as we said before, the plumbing industry. How long can I make this video?